Hello there, I'm Paul Belflam and this is Industrial Organization. This presentation is about hidden information problems. What we want to do is to understand why problems of hidden information may cause market unraveling. The background reading may be found in section 12.1.1 of the textbook. Let's go immediately to the model. Suppose we have a single seller and two potential levels of quality for a given product. We note quality by the letter S, and S can be either L for low quality or H for high quality. Okay, the seller faces different opportunity costs for the two qualities, and quite logically we assume that the cost for the high quality is larger than the cost for the low quality. So CH is larger than CL. Now, facing this seller, we have a unit mass of buyers. So think of a large number of buyers. They are characterized by how much they are willing to pay for a unit of a given quality. So we note for quality S, RS as this willingness to pay or valuation that the buyers have for this quality. And also quite logically, we assume that all consumers prefer high quality to the low quality, so their willingness to pay for high quality, RH, is larger than their willingness to pay for low quality, RL. Okay, and further we assume that what the consumers are willing to pay is larger than the opportunity cost of the sellers. So for both qualities, RS is larger than CS, meaning that there is room for trade. Right? So the maximum price that the buyers are willing to pay is larger than the minimum price that the seller demands for selling a particular quality. Okay, so this assumption means that if there was full information, so if the buyers knew the quality of the product before buying it, then trade would take place for both qualities, and the seller can profitably sell the product to buyers whatever the actual quality of the product. Okay, so I repeat, this is the direct consequence of this assumption here. Consumers are willing to pay more for each quality than what it costs for the seller to produce it. Okay, so the market would be efficient under full information. Now we want to see what happens when there is asymmetric information. Okay, so this is the case where the buyers cannot ascertain the quality of the product before buying it. Okay, so the seller will observe the quality, but the buyers will not. Okay, what the buyers know is that with some probability, and call this probability lambda, with some probability, the product is of high quality. Okay, and so if consumers believe that both qualities can be put on the market, then what they're willing to pay is something between RH, the valuation for the high quality, and RL, the valuation for the low quality. Okay, so something which is in between. Where in between? Well, it has to do with this probability that they expect of the product being of high quality. So with probability lambda, they would be willing to pay the high price, RH, but with probability 1 minus lambda, which is the probability that the product would be of low quality, they're willing to pay just RL. Okay, so here we've got a weighted sum of their willingnesses to pay, which is actually the average price that consumers are willing to pay facing a product of unknown quality and believing that the product can be either of high quality with probability lambda or of low quality with probability 1 minus lambda. Okay? Now, we analyze the following game with 3 stages. At the first stage, nature will draw the seller product quality for some known distribution. Okay, so the seller is not deciding here what is the quality of the product. We'll leave this for hidden action problems that we will consider in another presentation. But here, it's just a question of hidden information. The seller is not the one deciding what's the quality of the product. Think of the seller receiving the product, okay, which can be of high quality or low quality according to this distribution. So according to the probability that is given here. Okay. Now, what makes this problem a problem of hidden information is that the seller only has this information about the quality of the product. The buyers don't have this information. Okay. Now, based on this realization of the quality. The seller will decide whether and which price to post. So the seller may still decide not to put the product on the market. Okay, but if he does, then he has to decide at which price to post it. And based on that, the third stage, consumers form beliefs about the firm's product quality. And based on these beliefs, they decide whether to purchase the product or not. Okay, and they also observe the price, of course. Right, so this is the game that we want to analyze. Note that this game is particular for two reasons. There are 3 steps. Okay, so it's a dynamic game, but more importantly, there is asymmetric information. Okay, so the buyers, when they make the decision at the third stage, they don't know the quality of the product, and so they've got to form beliefs about this this quality. Okay, so we want to have an equilibrium concept that incorporates not only the dynamic aspect of the game, but also this asymmetric information. And so this is the equilibrium concept that we use. It's called perfect Bayesian Nash equilibrium. It's a Nash equilibrium, but it's refined along the following lines. This is, let me first say, this is the appropriate equilibrium concept for dynamic asymmetric information games. Okay, and without giving a formal definition, if you're interested, you can look at the appendix of the textbook. But what I just want to say here is the major idea behind this equilibrium concept. Okay, so what we want to incorporate is the following. Before making a decision, uninformed players, in this case the buyers, they have the opportunity to use the observation of other players' previous decisions to update their beliefs from the initial probability distribution used by nature. Okay, so in this present case, nature is deciding which quality the product is. Okay, so that gives some initial belief to the buyers. But by observing what the seller is going to do, the buyers can update their beliefs, can decide to change these beliefs. Okay, now the Nash equilibrium concept is refined by requiring that the beliefs of the buyers are formed optimally given the decisions of the seller, while the decisions of the seller are made optimally given the beliefs. Okay, so this is what I want you to take away from this concept. On top of requiring consistency between the actions of the different players, which is the basis of the Nash equilibrium concept, we add also a consistency with the beliefs formed by the uninformed players, those who don't observe, for example, in this case, the quality of the product. We'll see now how this operates. Right, so let's look at the potential perfect Bayesian Nash equilibria of this game. Okay, so let us first note that we have assumed in a very simple way here that all the buyers are the same, they are homogeneous. Okay, so it's as if there was a single group of identical buyers, which makes the demand totally inelastic and gives a lot of market power to the seller. So basically, in this simplifying setting, the seller can extract the full expected surplus from the buyers. Okay, which is to say that the seller will set the price at the maximum level that the buyers are willing to pay. This is not necessary for the result that we establish here. This is just a way to simplify the exposition. Now, first, suppose that both firms are active. So the seller receiving a low quality product or receiving a high quality product will decide to put the product on the market, okay, whatever the quality. Then, as we have discussed, the maximum price that buyers are willing to pay is this average sum, okay, lambda times RH plus 1 minus lambda times RL. Okay, now this is a reasonable assumption for the buyers to believe that both qualities are on the market, provided that this average price is larger than the cost for the seller to put the high quality on the market. Okay, remember that it's more costly to put the high quality on the market than it is to put the low quality. Okay, so if this price P is larger than CH, then there is a potential for profit for the high quality seller, and it makes sense then to believe that both products will be on the market. And if so, all consumers will buy, but uncertainty is not resolved. Okay, the consumers still have no idea which quality they buy before buying. Okay, so this is called the pooling equilibrium, because actually whether the product is of high quality or low quality, the same price will be posted by the seller. Okay, so the two types of seller, this is a jargon that we use, the two types of seller would pool by setting the same price. Okay, but all potential gains from trade are realized in that case. Now, the more interesting case is the following. What happens if this P, this average price, is lower than CH? Well, take the point of view of the seller now, and imagine a seller who has received a high quality product. Okay, the opportunity cost of selling that product is CH, but this cost is larger than the price the seller could expect to obtain. Okay, so such seller will not put the product on the market. Okay, so will not participate. And so this is something that the consumers can figure out, and they will realize in that case that there is no reason to believe that both qualities would be put on the market. Okay, they just realize, as we did now, that a high quality firm will not participate. Okay, and so in that case, as we explained before, the buyers will update what they were believing in the first place. Okay, they started by believing that both qualities would be on the market, but now they realize that only the low quality will be put on the market. And so what they're willing to pay is no longer this price P, sorry, let me show it again on the previous slide, this average price that is the average of their willingness to pay if both qualities are on the market. Now what they're willing to pay is just their valuation for a low quality product, because they figure out that only the low quality product will be put on the market. Okay, and at that price, there is even more reason for the high quality seller not to participate. And so we have found this consistency we were requiring between the behavior or the decision of the seller and the beliefs of the buyers. Okay, so the bottom line of this case is that only the low quality survives. This is what we call adverse selection. Okay, adverse selection because the market has selected only the low quality product, and the high quality product is no longer put on the market. Right? So to summarize, let us represent the perfect Bayesian-Nash equilibrium on a graph. So to make sure we understand what is drawn here, on the horizontal axis I have CH. Remember, this is the opportunity cost for a seller of a high quality product. And on the vertical axis, I measure the expected quality. Okay, so it can be either the average willingness to pay or the low willingness to pay. Now, what are these two lines? The first line on the top shows that we have an equilibrium where consumers believe that both qualities are on the market. And so remember, their willingness to pay is this average sum of their willingness to pay for the high quality and the low quality. And this is the price that a seller of high quality or a seller of low quality would quote. Okay, and this is consistent with both qualities being on the market because CH, the cost of the high quality product, is below this price. Okay, so for CH below lambda RH plus 1 minus lambda RL, we have an equilibrium which we called pooling equilibrium. Okay, now we also have another equilibrium, which is when this cost CH is larger than RL. Okay, and so it makes sense for consumers to believe that the high quality seller would not participate, and if the high quality seller doesn't participate, only the low quality will be on the market, and so the maximum price that consumers are willing to pay is no larger than RL. Okay, and again, this is consistent with what the consumers believe and what the sellers do. Okay, again, I use sellers in plural because I mean the seller either having a low quality product or the seller having a high quality product. Okay, so I repeat, for any CH larger than RL, and this is what this line means, we have another equilibrium, which is a separating equilibrium here, because a high quality seller will not participate, whereas a low quality seller decides to put the product on the market at price P is equal to RL. Okay, just note before we stop that there is an area here of parameters when CH is between these two values, where we've got the coexistence of two perfect Bayesian-Nash equilibria. Okay, so let's summarize. The main takeaway is the following. In markets in which product quality is exogenous but unobservable by buyers, high quality products may not be offered for sale. Okay, so there is an inefficiency here, a market failure, which is due to the presence of asymmetric information. Only the low quality stays on the market, and the high quality product are not offered for sale. This is what is called adverse selection. Now, this result can be generalized, and this is due to the pioneering work of George Akerlof, who won the Nobel Prize in Economics in 2001, and he was actually rewarded for his work on the economics of information, and one of the first papers he published is this one, The Market for Lemons, Quality Uncertainty and the Market Mechanism. Lemon is the nickname for a used car that is of low quality. Okay, so that was the main example he was taking in his article, and he shows that this argument we just made in a very simple setting can be generalized to any experience good and for a continuum of quality levels, not just two qualities as we had in the example I showed you. And it may lead to what he calls a complete unraveling of the market. Only the lowest quality would survive in the market. Okay, so that's the generalization of the argument we just made. And that's it for this presentation. Thank you for your attention.